right, good morning everybody. So yesterday we had the quiz and it looks like most of you got it in. If you've not got the quiz in, please get it in, or the test. Gosh, I hate to give kids 0, but you got to get your job done. Oh well, so today is, today's the fall solstice. I mean the fall equinox. 9/22, it's equinox today. That means the start of fall. Okay. So, today, what are we talking about? Polynomials. Polynomials. Okay, let's see. Polynomials mean many terms. Or, poly means many, nomials means like numbers. Many numbers, many terms, okay? So, to be a polynomial, it has to have, must have whole number exponents. Okay, go ahead and write that down. To be a polynomial, it must have whole number exponents, okay? I'm going to give you some examples, okay? I'll do this and then I'll come back up to here, okay? As some examples. Example, how about a whole 3x cubed plus a 5x squared? That's a polynomial. How about a 4x to the third minus 8x squared plus 5x? That's a polynomial. How about a 4x squared y? That's a polynomial. And even something as long as this. We could have a 5x to the fourth minus a 3x cubed plus a 2x squared minus a 5x plus 1. That's a polynomial, many terms, okay? So many terms, and what we want to do is actually give names to some of these. Not to all of them, but some of these, okay? So what I would do, the first one, because there's 2 terms, that's a binomial. 2 terms, binomial. Like a bicycle, binomial, 2 terms, 2 terms, right? Now, the next example, 1, 2, 3, it's got 3 terms. We call that a trinomial, like a tricycle. That one's a trinomial. Now, this is just 1 term. It's all squishy together because terms are separated by pluses or minuses. This is a single term, so it's called a monomial. Okay, if it's got a single term. Now, if it has more than 3 terms, 1, 2, 3, 4, 5. Anything bigger than 3 terms, we just call it a polynomial because it just gets ridiculous. So we're just going to call this a polynomial. Polynomial. Okay, so polynomials. Oh, by the way, something that would not be, let me show you an example. Example, a 5x to the negative 3, not a polynomial, not, because that's not a whole number. You see, let's go back to our definition. Whole number, these are these numbers here. 0, 1, 2, 3, ... Okay? Negative 3, that is not a whole number exponent. That is not a polynomial, okay? All right. Now, the degree of the polynomial is the biggest exponent. And that's really helpful someday, but it's the biggest exponent. So let's go back down to my examples here, okay? So the degree, let's see here. All right. So the degree of this one, degree, I'll put D for degree, okay, is 3. Okay. The degree of this one is also 3 because it's the biggest exponent. Exponent, not numbers. This one's kind of tricky because it's squishy together. So we go the 2 plus 1 more, so we say the degree is 3 in this case. Okay. And this one, the biggest exponent is the 4. Okay. Now, we also have things called leading coefficients. The number in the front, 3. A leading coefficient leads the 4. Leading coefficient, the 4 leading coefficient is the 5, okay? Now, standard form, that's biggest to smallest. Biggest exponent, though. Biggest exponent to my smallest. It's got to be in order. Standard form is order. We need it to be in order, okay? So biggest exponent to smallest exponent. So let me show you what I mean. So if I look at example 1, it's out of order. That has to go first because it's the x to the cube. That's the biggest. It's out of order. That's got to go next, biggest to smallest. That's got to go next, and finally the negative 2's got to go to the end. So if we rewrite it in standard form, we'll go p of x looks better like this. A 7x cubed plus a 5x squared plus a 4x minus 2. Okay? The degree we know is the biggest exponent. That's the degree. So the degree of this one is 3. Degree is 3, right? Biggest exponent. And the name, well, let's see. It has 1, 2, 3, 4 terms. Well, it's not a trinomial. It's got to be bigger than 3, so we're just going to call it a polynomial. Polynomial. Anything bigger than 3 terms. You've got monomial, binomial, trinomial. Anything bigger than that, we just call it polynomial. It gets silly. Quadrinomial and pentanomial and hexanomial and septinomial and octanomial. It's like, no, too many. We'll just call it anything bigger than 3, we'll call it a polynomial. Okay, the leading coefficient. What is in the charge? What's in the lead? That number is in the lead. It's in the front. That's my leading coefficient. It is the first number in front of a variable. It is the 7 is the leading coefficient after you rewrite it in standard form. Not the 4. Nope. Not the 4. Nope. Not the 4. You have to rewrite it first. The leading coefficient is the 7. Okay? I'm going to turn my page. Here we go. Okay, simplify, adding like terms. Okay, if they're the same, we add them. So if they're the same, add them. But don't change them. Don't change them. So it's like saying, I've got 3x cubed, and I'm going to subtract 4x cubed. So I put these two together. So find the ones that are the same. This one's the same as this, is the same as this one. So 3x cubed minus a 4x cubed makes a negative 1x cubed. Okay, if they're the same, so I've got a 2x squared with a 2x squared, okay? 2x squared plus another 2x squared makes a 4x squared, okay? They're the same. Put them together. Let's see, I've got a negative 5x and a 3x, so those are the same, okay? Okay, so I've got that and that are the same. So if they're the same, combine them. Negative 5x plus 3x makes a negative 2x. And that is my answer because I cannot combine things that are not the same. Done. Easy, right? Subtracting exponents. Well, now if you subtract exponents, I like to actually, I'm going to say push subtraction sign through and add. Okay, let's write that down. What does that mean? Push subtraction sign through and add. Okay, now you don't have to do this, but it just keeps me from making dumb mistakes. Because gosh, I make dumb mistakes all the time. So here's what would happen. See, I would be really like subtracting 5x, but it's not really subtracting 5x. Or subtracting negative 5x. It's really going to be minus a minus, which is a plus. That just gets confusing, right? And then a negative 3x with a negative 5x, that just gets confusing. So what I do is this, just to make it easier. It takes me an extra step. With this negative sign, I distribute through. And then I add, and then add. Okay, so let me do that. Let me rewrite it. So this becomes a negative 7x cubed. Because I'm going to bring the negative through. This becomes a negative 2x squared. Negative, negative, that becomes a positive 5x. Negative, negative makes a positive 8. So then when I bring back down my 4x cubed minus my 3x plus my 7, then I can combine terms just like I did up above. Okay, so what's the same? 4x cubed and a minus 7x cubed. Those two can be put together to make a negative 3x cubed. Okay, what else is the same? Well, I've got, that's the only x squared, isn't it? All by himself. So we're just going to write down the negative 2x squared. And negative 3x, positive 5x, I can combine, or in a sense subtract those, right? So I get a positive 2x. And finally the 7, sitting all by itself, the 7, so I go plus 7. It is in standard form. It needs to be cubed, squared, to the 1 power 9. Okay? All right. Hopefully this is starting to make a little bit of sense. There's my answer. Now, example 4 is just like what we did, except it's a little bit bigger, a little bit more complicated, okay? So, what I want to do is bring the negative through. Okay, let's bring the negative through. I just want to bring it through. I'm going to go and distribute the negative through so I don't make dumb mistakes. I only do this with subtract, only. So I get a negative 3xy, and then a negative negative, I get a positive 4xy squared. Negative, bring it through, I get a negative 5x squared y. All right, let's bring down the first part. The first part's still my 3x squared y plus my 5xy squared plus xy, okay? Now, what's the same? Well, they kind of look like a mess, but you gotta be careful. This 3x squared y is the same as this negative 5x squared y. They're the same. These are the same. They're not the same as this. It's different. Only one's the same. So these two, I'm going to write as a negative 2x squared y. And then what's next? Well, let's see what's the same. I believe that I've got this 5xy squared with this 4xy squared. So those two together make a positive 9xy squared. And then finally, what do I have left? Well, I've got an xy with a negative 3xy. Now that's like a 1. You don't see a 1, but there's a 1 there. Makes a negative 2xy. Okay, so that's not too bad. The homework is out of the journal on page 35. Look in Canvas to find out what it is, and it'll also be an exercise. So I will talk to you tomorrow.